Guys, welcome back. We have another question here. They're saying PQRS is a quadrilateral with PQR and S. We can see the coordinates. No fancy information here. So we just have to go through the sketch. So we have P, we have Q, we have R, and then we have S. No problem. So now let's go to the questions. There's nothing fancy, no information, nothing. So now we just go straight to the questions. So now the first question say prove that triangle QRS is a right angled triangle. So now where is triangle QRS? We have Q, we have R, and we have S. I tried to highlight that triangle. This is the triangle Q. This is Q R S. So is that triangle. So now if you look at that triangle, QS can be the hypotenuse, and from what we know from the right angled triangle, if this is a right angled triangle and then this is the hypotenuse, we know the angle that is opposite to the hypotenuse must be 90 degrees. So now if this is a right angled triangle, QS has to be the hypotenuse and the angle R has to be 90 degrees. So that is a right angle triangle. So now how do you prove that this angle is 90 degrees? Because if we can prove that this angle is 90 degrees, then triangle QRS will be a right angle triangle. Point number 7 in the information part, I showed you or I gave you hints on how to prove 90 degrees or to prove perpendicular lines. Remember I said the first one, you can prove the Pythagoras theorem, or you can find the gradient of each line and show that the product of the gradient is -1. So we're just going to do the first one and do the second one just as to show you how do you do these things, how do you prove them. So now we are going to find the length of QS but squared. Remember the distance formula is Q, so we're going to find QS but squared. So QS squared, okay, let me not do new things. QS is equals to the square root of x2 minus x1 squared plus y2 minus y1 squared. You see, every time I always start with the formula. I write the formula first so that I know my substitutions will be correct. So now if you look at QS, no problem, is Q. Remember, we can say this is x1, y1, and this is x2, y2. So now let's try to calculate the length of QS. Let's substitute. So now what is QS? What is x2? X2 is 3. So we substitute into the formula. We have 3 minus, and then what is our x1 here? We go to the naming. Our x1 was -5. So we have minus -5 all squared plus, and then what is our y2? Our y2 is -1, so we have -1 minus, we got that -1 here because we named, and then our y2, y1 and y1 will be -2, so we have minus -2 squared. So we put the whole thing into the calculator. So we have the square root of 3 minus -5 squared plus -1 minus -2 squared, and that gives us the square root of 65. So we have the square root of 65. So that's QS. But remember, we said we need the squared. We need them squared. So we need to square both sides. So QS squared will be 65. So now let's go to the second one. Instead of putting the square root, guys, we're going to write the formula without the square root. Instead, we're going to use the squared. So we found QS. Now we need to find RS. So now finding RS, we're going to use squared because we don't want to do this step. So we're squaring everything. So that's going to be x2 minus x1 squared plus y2 minus y1 squared. This is the same thing as the distance formula. It's just that instead of writing the square root, we write them with squared. So now let's go ahead and make substitutions. So what is we have RS. So since we have x2, y2, this can be x1, y1. No problem. So now let's go ahead and make substitutions. So what is our x2? We go to the sketch. Our x2 is 3. So we will have 3 minus. And then what is our x1? Going to the sketch. x1 is 1 because we named x1 there. So we have 1 squared plus. And then what is our y2? Going to the sketch, we have -1 as our y2. So we have -1 minus. And then go again because the formula is y2 minus y1. So what is our y1? That's -5. So we have minus into -5 squared. So this is rs squared, rs squared. Now let's go and put that in a calculator. So 3 minus 1 squared plus -1 minus -5 squared. So that's 20. So we have 20 here. Remember, we need to find all the sides, but we need them squared. So now let's go to the last one. We have QS, we have RS, and then we need QR. So now QR squared equal, guys, I'm not going to write the formula this time. Instead, I'm going to use the same formula. So for QS, I'm just going to make substitutions. So here for QR, in fact, not QS. So here is our QR. Are you aware we have x1, y1? We have x1, y1. We can make one of these things 2. So this will be x2, y2. That will be x1, y1. So now let's make substitutions. What is our x2? If we come here, our x2 is 1. So we will have 1 minus. And then what is our x1? Our x1 is -5. So we will have minus -5 squared plus. And then what is our y2? So our y2, if we come to the sketch, is -5. So we will have -5 minus, and then what is our y1? Our y1 is -2. So we have -2. So this is QR squared. So now let's go ahead and put that in the calculator and see what we find. So 1 minus -5 squared plus -5 minus -2 squared. So we get a nice number, which is 45. So now what do you notice about the 2 in relation to that? Therefore, it's clear to see that QS squared is equal to RS squared plus 45 squared. Oh no, not 45, plus QR squared. And then if this is true, it is true by Pythagoras. So if that's true, therefore triangle QRS is a right angled triangle. So this is the first approach that you can do to proving the Pythagoras theorem. If you can show that the hypotenuse squared is equal to the sum of 2 adjacent sides squared, and then that will mean that the triangle is a right angle triangle. And how do we know it's a right angle triangle? Because it agrees with Pythagoras. So, or it coincides with Pythagoras, or agrees. So now this is the first option. So now option 2, Remember, we have two options. I said you can either prove by Pythagoras, or you can find the gradients of each line and show that m1 times m2 is -1. So now let's go ahead and do that. Let's find the gradient of m1 and m2. So now if you come to the sketch, what will be m1? M1 will be the gradient of this line. So we need the gradient of QRS. So the gradient of RS, the formula for gradient is y2 minus y1 over x2 minus x1. So now let's go ahead and find the gradient. Since we have x2, y2 and x2, y2, we can make this one to be 1, 1, or we can change this one to be 1, 1, no problem. So now the gradient of RS, what is our y2? If you look at that, our y2 here it is -5. So we will have -5 minus, and then what is our y1? Y1 from the naming we can see that is -1. So we will have -1 over, and then what is our x2? Our x2 is here, that's 1. So we will have 1 minus, and then what is our x1? So our x1 is there, so that's 3. So we put the whole thing in our calculator. So we have -5 minus -1. Close it. Then 1 minus 3. So the answer is 2. So now we know the gradient of RS. We know the gradient of this line. And then we need the gradient of that line. So the gradient of QR equal y2 minus y1 over x2 minus x1. Since we know, we have named, we have x2, y2, and then we have x1, y1. We can go ahead and make substitutions. So what is our x, y2? That is -5. So we have -5 minus, and what is our y1? Our y1 is -2. So we have minus -2 all over. So now what is our x2? From the naming, guys, we're not calculating these things. We just take them from the naming. We're saying this is x2. So the value of x2 is 1. So we will have 1 minus, and then what is our x1? Our x1 is -5. So we'll have 1 minus -5. And then we find the gradient of QR. Now let's go ahead and put that in our calculator. So we have -5 minus -2 all over 1 minus -5. So we get -½ into our calculator, So we have -½ So now what do you notice about the two answers? Let's find the product, because I said you find the gradient of each line and show that m1 times m2 is -1. So now we have to multiply the gradient. So the gradient of RS multiplied by the gradient of QR equal, the gradient of RS is 2 multiplied by -1/2. So that is -1. So that means angle R is 90 degrees. So if angle R is 90 degrees, therefore triangle QRS is a right angled triangle. So you can go through the video multiple times to try to see the idea. How do we prove that a triangle is a right angled triangle? Or how do you prove that we have 90 degrees in a triangle? Or how do you prove that those three cases, the perpendicular, the right angle triangle, at 90 degrees, they have the same approach. Basically, you don't change approaches if you are solving them. So now, looking at the second question. So the second question says, prove whether triangle QRS is isosceles or not. So the marker location is 5. So let's recap, and this is 2.2. What did we say about an isosceles triangle? We said an isosceles triangle is a triangle that has two equal sides. So now to be able to prove this question, we need to find the length of each side, because in the length of each side in triangle QRS. So here is triangle QRS. So we need to find the length of this side and that one. So now let's go ahead and do that. Let's start with QRSR first. So from using the distance formula, SR equal the square root of x2 minus x1 squared plus y2 minus y1 squared. So let's see the naming. We did some naming earlier, so we need to use the same naming, I think. So now we need SR. So we have, you see the naming is correct. We have x2, y2, and then we have x1, y1. We can use the same naming. So now what are we going to substitute for x2? If you look at SR, our x2 was 1. So we have 1 minus, and then what is our x1? Our x1 was here, which is 3. So we have 1 minus 3 all squared plus, and then our y2 was a negative 5. So there, from the naming, so that is negative 5 minus, and then our y1 was negative 1 from the naming, all squared. So now we put the whole thing into our calculator to find the length of SR. So the square root of 1 minus 3 squared plus negative 5 minus negative 1 squared. So if you put that in a calculator, you get 2 root 5. Don't write decimals. So we have 2 root 5 units. So we're done with the first side. We need to find the second side, which is QR. So now let's go ahead and do that. So with the length of QR, we write the formula x2 minus x1 squared plus y2 minus y1 squared. So that's QR. So now from the naming, are you aware we have x2, y2, and then we have x1, y1? So no problem, it's a bonus. Can just substitute. So now what's going to be our x2? If you read this thing, this is x2. So our x2 will be 1. So we'll have 1 minus, and then what's going to be our x1? Our x1 is right here. That is going to be negative 5. So we have minus negative 5 squared plus, and then what is our y2? Our y2 from the naming there is negative 5. So we have negative 5 minus, and then what's going to be our y1? Our y1 from the naming, as you can see, it's negative 2. So we have minus negative 2 all squared. So let's go ahead and put that into our calculator to find the length of QR. So we have square root 1 minus negative 5 squared plus negative 5 minus negative 2 squared. What is the answer? We get 3 root 5. No problem. So this is 3 root 5. Remember, isosceles triangle has two equal sides. So now let's look at QR. But okay, remember we did this thing when we found the length when we were trying to prove the Pythagoras theorem. So you see here, we found the length when we're trying to prove the Pythagoras theorem. We could have just taken the length as they are, but no problem, no stress. We can calculate. We can, for the last one, I don't think it's necessary to, because we already calculated the last one. So the last one, QS, was the square root of 65. See, the square root of 65. So it was not necessary to calculate other length, all these lengths, because we did that already. but no problem. Now, what do you say? This one, this one, this one, are they equal? No, they're not equal. So, therefore, triangle QRS is not isosceles. Why are we saying it's not isosceles? Because we don't have two pairs of equal sides. If we had two pairs of equal sides, we are going to say it's isosceles. So now let's go to the another next question, which is this one. The question say determine the coordinates of t. Okay, we don't know what is t, where is t. They say if t, which has the coordinates 7 is to y, okay, let's highlight t as the coordinates 7 is to y, and t, r, s are collinear. So let's go ahead and find t, r, and r and s. So this is r and this is s. So that means t is somewhere here. So we have t there with the coordinates 7 and y. Why do we have t there? Because they said they are collinear and they lie on the same line. So if we were to create a sketch, our own sketch, so this is r, which is the coordinates 1 and -5, and this is what you have to do always if you are told that the points are collinear, or if you can see that they are collinear, you need to start by writing down the formula for the gradient. So this is what we have. We have RTS. We are told that T is somewhere there such that the points are collinear, or it can be outer. Since it has 7, obviously the T has to be outer, but it's not a problem. We know they are collinear, so it's not a problem. So now what we know is the gradient of RT, the gradient of the 2 points, is equals to the gradient of TS, and is also equal to the gradient of the outer ones, which is RS. And I said, if you have such case, calculate the gradient for each part. So if you calculate the gradient for RT, the gradient, the formula is, we know it's y2 minus y1 over x2 minus x1. So now this can be x1, y1, this can be x2, y2. We start with RT first. So now substituting into the formula, what is our y2? Our y2 is y minus, and then what is our y1? Our y1 is -5, so we have plus 5, because the formula is minus and that 5 is minus, so those two minus, they make a positive. So now what is x2? X2 is 7 minus, and then what is your x1? Our x1 is 1, so this is 1 equal. Then we go to the next one, which is TS, the 2. Since we have x2, y2, that one can be x1, y1. We are calculating the gradient. So what is our y2? For we are here. What is our y2? Our y2 is y. So we will have y minus, and then what is our y1? Our y1 is -1. So this negative and this negative, they can make positive. So we have plus 1 over. And then what is our x2? We're on the 2 points. Our x2 is 7 minus, and then what is our x1? And obviously that's 3. Then we go. So we go to the last part, which is RS. Since we have x1, y1, x1, y1, we can change 1 to be x2, y2. No problem. So now the formula is y2. So if you look at RS, what is our y2? So that's -1 minus, and then what is our y1? So this negative and this negative, they make plus 5 over. And then what is our x2? Our x2 is 3, so we have 3 minus, and then what is our x1? That's 2. Go ahead and calculate. So we have y plus 5 over 7 minus 1, that's 6 equal. Then we have y plus 1 there over 7 minus 3, that's 4 equal. Then -1, then that one we use the calculator. negative 1 plus 5 divided by 3 minus 2. That's 4. So we have 4. So now the nice thing, all these three things or fractions or terms, they are equal. So now we can take 2, like if you take this 2 and then this will be over 1 and then you cross multiply. So y plus 1 multiplied by 1, that is y plus 1 equal 4 times 4, that's 16. And then if you take 1 to that side, y will be 16 minus 1, therefore y will be 15. It's up to you. Sorry. Or if you take this one and that one, in such a way you will have 1 plus 5 over 6 equal 4 over 1. And then if you cross multiply, y plus 5 times 1, that's just y plus 5. And then 6 times 4, that's 24. So if you take this one to that side, that will be 24 minus 5. So y will be 19. So now on the last question, which is determine 2.4. So 2.4 says determine the equation of a line perpendicular to PQ passing through R. So I'm just going to give you a hint in the comment section. You can send the answer for this question. I'm just going to give you a hint. They're saying determine the equation of line perpendicular to PQ. Okay, this line is perpendicular to PQ, and then they're saying passing through R. So that means that line passes through this point. So that's the picture that we have. So it's perpendicular to PQ. So that is the picture of that line. So my hint is, we know that line passes through R. That's a nice thing. And then we know once you have 90 degrees, you know the gradient of the first line multiplied by the gradient of the second line, that must give you negative 1. So to find 2.4, I'm just going to give you a hint. To find 2.4, you know the gradient of PQ multiplied by the gradient of that line which passes through, which is perpendicular to PQ, is negative 1. So you find the gradient and then you find a point that lies on that line. So obviously a point that lies on that line, it has to be R because it passes through R. And then in that point will be your x1 and y1.